All right, so we're going to look at what we call Pythagoras theorem. But before we can do that, you see, we're going to look at certain properties of a right angle triangle. All right, so all right, so this is typically a right angle triangle. And we know it's a right angle triangle because every right angle triangle must have a 90-degree angle. And we use a symbol there, this little square thing, to represent 90 degrees. So in a right angle triangle.
Your screen is blank.
My screen is blank?
See anything?
Yes, sir.
Yes.
Oh Lord. Hold on here. So are you seeing this triangle now?
Yes, sir.
Okay. All right. All right. All right. So this is a right angle triangle. And typically every right angle triangle must have a 90-degree. All right. So if it doesn't have a 90-degree in it, it's not called a right angle triangle. It's either an isosceles, a scalene, obtuse, reflex, equilateral, or even a scalene triangle. All right. So in a right angle triangle, there's always one side that is the longest side. So you have one side that is the longest side, and the other two sides are always the short sides. Now the longest side is called the hypotenuse. I will just use HYP for short for hypotenuse. Now the hypotenuse is, by the way, this is the hypotenuse. All right, and the hypotenuse is always opposite the right angle triangle.
Also the longest side. It's also the longest side.
Yes, man. Yes, it is the longest side. And what happened is sometimes when these drawings are presented to you, sometimes it's kind of difficult to actually look and determine which side is actually the longest side. And sometimes you can't even measure because sometimes these diagrams are not drawn to scale. So one of the best alternatives to identify the longest side is to look to see which side is opposite the right angle. All right. So if I have something like this, so by the way, if this is the hypotenuse, so therefore let's call this A and B. So those sides will be the two what? The short sides. So let me draw another right angle triangle. I'm going to give some names. T, T, S. All right. Can someone tell me which side is the hypotenuse?
Yes.
It will be PS. Why? Because PS is directly
Opposite of
the right angle. All right. Are we clear? Everybody following?
Yes, sir.
All right. Let me try to tickle your brain a little bit. X, Y, Z. All right. Now, which side is the hypotenuse?
XY.
X and Y.
XY.
It will be
XY.
XY, not true? Yes. Because it is directly in front of it's opposite the what? The right angle. Now, if you look at this diagram, I mean, ZY could also be considered the longest side, not true? Yeah. But to be absolutely sure, we use that strategy. All right. So it is always important to learn how to identify the hypotenuse of a right angle triangle. All right, so we're gonna move on to some other properties of a right angle triangle. All right. You know what? I'm gonna try and save all these slides. I can, you know. All right, let's look at another feature of a right angle triangle, which is important in trigonometry. I hope you guys have your scientific calculator, because I can't find mine right now. Where's mine? Somewhere. All right. Now, in a right angle triangle, right? Apart from the hypotenuse, that's something called the adjacent side.
Yes.
Adjacent side, and you have something called the opposite side. All right. Now, the adjacent side and opposite side, those sides are determined in relation to what we call the reference angle. Reference angle. All right. So I'm going to put a reference angle here. Let's call it theta.
Yes.
All right. No, technically speaking, the hypotenuse can't change. It's always opposite the right angle. But the adjacent side and opposite side varies. So the adjacent side and opposite side would have been also be the two short sides. Now, this is how you do it, right? So the adjacent side, listen carefully, is always between the reference angle. Where's the reference angle? That is our reference angle, true. So the adjacent side is always between the reference angle and the right angle. So therefore, let's call this A, point A, B, and C. So this side is called the adjacent side. Why? Because any side that is between what? The reference angle and the right angle is called the adjacent side. Therefore, the other side must be the what? The opposite.
Opposite.
So what do you notice I do? I work with the hypotenuse, and then I work with the adjacent, and I leave the opposite for last. So, and that is the strategy of labeling your triangle. Any questions?
No, sir.
Let me. Hope you guys are writing. Look at this one for me. All right, who wants to volunteer and tell us which side is the hypotenuse?
Sir, A and C.
AC. Thank you. Very good. So well, don't say A and C, just say AC here. AC is the hypotenuse. All right, somebody else. Can somebody else tell me what the adjacent side is?
AB.
It will be AB. Why is it AB?
Because it is in between the reference angle and the right angle.
Very good.
Yes.
Awesome. Right. So any side that's between the reference angle and the right angle is called the adjacent side. All right. So therefore, CB must be the what? Or BC must be the
Opposite.
opposite. This is very important, you know. If you can't figure this out, trust me, you can't understand trigonometry. And let me tell you, this part is probably one of the hardest, one of the part that gets students off track. All right, let me see if I can. By the way, any questions so far? Any questions for me? Anybody not clear or not sure about anything?
Sorry, repeat that adjacent side. Never hear.
The adjacent side, all right, very good. Okay, so in order for you to find the adjacent side, by the way, do you know to find the hypotenuse?
Yes, sir.
All right, so the adjacent side is always between the reference angle and the right angle. That's the adjacent side. So between the reference angle here and the right angle. All right, so let's call this 1, 2. All right, let me give you another one just to be absolutely sure that you're following. All right, so what I want to do is in your various WhatsApp group, because I can't hold on. This thing about chat, right? Oh, sorry, we can use this chart. In this chart, just tell me what is what are the different sides? Just write X, Y. You can use you can use H for hypotenuse, O for opposite, and H, and A for adjacent. So tell me what side XY is, what side YZ is, and what side XZ is. Just do that for me in the chat. So you don't have to write opposite, the word opposite, or the word. Just write O, H, and A. I'll give you about 5 minutes to do that. All right, I'm seeing some posts coming in. All right, so if you're just joining us, we're doing a little activity. All right, labeling the sides of triangle 3, whether it's opposite, hypotenuse, or adjacent. All right. All right, so I was okay. Let me see. So this planter is saying XY. I was hoping you guys would just put the whole thing in in one chat, like, but it is what it is. So Splanter is saying that XY is the adjacent, correct? Mrs. Walker Smith is saying XY is also the adjacent, correct? Macadia is also saying that YZ is the hypotenuse, correct? Very good. Duhaney is saying XY is adjacent. Mrs. Smith, YZ the hypo. Splummer, YZ correct. Ms. Planter is also saying that YZ is the hypotenuse. Planter is saying XZ is the Opposite, correct. Duhaney, correct. Smith, correct. Duhaney, correct. All right. And Alexa is saying, well, all of those are correct. All right, very good. Some person are even WhatsApping me in their various WhatsApp group. Doesn't matter. Sir, let me, okay. Okay, so yes, all of you are correct. So clearly, the side that is opposite the right angle is the hypotenuse, which is YZ. So that's the hypotenuse. And the side that is between the right angle and the reference angle is called the adjacent side, ADJ. And obviously XY will be the, sorry, XZ will be the opposite side. Very good. All right, any questions? Oh, by the way, sometimes, let me show you something. All right, so whenever you're labeling a right angle triangle, this side is XY. All right, so you can't say this side is X or this side is Y. It has to be XY. You don't want to say X and Y. Or you could say X to Y. All right. X to Z is right here. And Y to Z is on this side. Now, let me show you something. Now, opposite vertex or vertices X is common X. All right, you follow? MOE, Ministry of Education. All right. So YZ can also be called common letter what? X. And then opposite Y is common Y. All right. And opposite point Z is what? Common Z. So you can label your triangle like that. I'm just reminded that the Zoom platform takes a lot, eats up a lot of data here. You have to have strong internet to use Zoom. All right, so let me try to save this again. All right, let us get to Pythagoras, Mr. Pythagoras, and hear what he has to talk about. All right, now, Mr. Pythagoras, very important in mathematics and in construction, believe it or not. Now, this is what he said. So, if you have a right angle triangle, right? If you're right angle, let's call this side C, let's call it side A, and let's call it side B. Now, class, let me ask a question. Obviously, C would have been the longest side, correct? So therefore, side A and side B would have been the short side. So what Pythagoras was saying, so this is Pythagoras' theorem. Mr. Pythagoras was saying that, you see, watch out now, look, watch carefully, or listen carefully. If you sum the squares of the two short sides, because these are the short sides, correct? You're gonna get the square of the longest side. So that's what Mr. Pythagoras devised. And this was a remarkable mathematical discovery because it's absolutely true. It can be proven, right? Let me give an example of how to use Pythagoras. Any questions, by the way? Not yet? All right. Let me give an example. Let's call this 4 centimeters. Let's call this 3 centimeters. All right. So, it's an example. Let's call this A, B, and C. So the question says, find side AB. That's a question. All right, let me give you a minute to take out a question. There's one thing with online learning though, you know, it's very slow, but you guys can write, catch up on me, not true? When I'm in class and I'm writing really fast, it's kind of hard, but you guys can actually catch up on me. And you can see how this topic is very important. I mean, think about this. Let us say this is a wall. This is a wall, right? Oops. Oh my, hold on, hold on, hold on. So let us say this is a wall, or even a tree, or a building. All right, and this is a river. Between C and B is a river. All right, and these are C and B are the banks of a river, and somebody needs rescuing, right? And they're on top of this building on the other side of the river. You can actually use Pythagoras theorem and calculate the exact length of rope you need, or even a ladder. All right? Yeah, man. Very practical, trust me. All right, so the question says to find side AB. So you need to ask yourself this question before you start. Number one, is this triangle a right angle triangle? Yes, it is. Oh, by the way, Pythagoras theorem only works with right angle triangle. I should probably make a note here. Only works with right triangle. All right, I'm going to write the word triangle, so let's draw one. Right? So Pythagoras theorem only works with what? Right angle triangle. And another thing about Pythagoras theorem is that Pythagoras theorem only find what? Unknown sides. So it only find sides of a triangle. And they must give you two sides. All right, so they give you two sides of a right angle triangle. You use PT to find what? The other side. All right, now, so we want to find we want to find side AB. No, it asks itself this question: is side AB what we're finding the hypotenuse? Somebody tell me. Is AB the hypotenuse? Yes or no?
Yes, sir.
It is,
Yes, sir.
right. So you see, it's very important, you know why? Because sometimes they'll flip around the question where they give you the hypotenuse and they ask to find out what? A short side. So let's go to Mr. Pythagoras now. So what I'm going to say, I'm gonna flip around his formula. So rather than writing a squared plus b squared equals c squared, I'm gonna write c squared is equal to what? A squared plus b squared. Now, ladies and gentlemen, what does a c squared represent? In the formula, c squared would represent the hypotenuse, and the a and the b are the short sides. All right. So in this case, now I'm not gonna write c squared. I'm gonna write what the question actually says, which is what? AB. So therefore, a squared and b squared are two short sides. Now, it could be any one of them here. Don't stress yourself. So I'm going to use that 3 squared and what? 4 squared. And what is 3 squared, class?
9,
9. Very good. And 4 squared is?
16,
And what's 9 plus 16?
25.
25. So therefore, a b squared is equal to 25, but we don't want ab squared. What we want ab.
They want
Right, no.
square root t.
Very good, Gabriel. So
Right.
to get
Sir,
rid of,
still Haley.
oh, I'm sorry.
It's fine.
All right. So,
You forgot my voice.
all right. Yeah, well, so we square root both sides. All right. Now it's an equation, and all equations have to be balanced. And what you do on the left, you have to do it on the what? On the right. So therefore, AB is equal to root 25. And what's root 25?
5
5. So the answer is just 5
centimeter.
centimeter. All right, and that's how you compute Pythagoras theorem. Any questions before I give you one to try? All right. Let me give you a minute to write this off.
Good afternoon, sir.
Yes,
I would like to ask a question. How comes in the answer you didn't have B? A is only A.
No, man, I was just testing you guys. Sorry.
Funny.
Yeah. Can I move on? Anybody writing? Okay, no response.
Hold on, sir. Hold on. Wait.
Right, so I'm saving these files here. These things.
Sir, are you
Now,
going to post it on your YouTube channel or something?
yes, man. I'm gonna post these on right after I finish. After it's been uploaded, I'm gonna post it on my channel, and I'm also gonna send these slides. I should probably name them. Not sure. This is slide 3.
Sir, don't take it off yet. Sir,
Yes.
how is your Easter going?
It's, well, I'm alive, so I have to give thanks.
Good, good.
Yeah, man. All right. Are you guys finished now? All right.
Yes.
I'm going to
Yes, sir.
um I'm going to give you guys 2 to try,
Okay.
and I want to post your answer in this chat.
This chat.
Yeah, man, this Zoom chat. So class activity. All right, so the question mark means yeah.
Find that side.
All right, to make it easier, say don't post 2 separate answer within it. Just do both of them and make one post. It's kind of confusing, or kind of repetitive. So remember, you're supposed to have your calculator with you. All right, so find AB and XY using Pythagoras theorem. You're supposed to get some nice whole numbers, but in fact, you also can get decimals. Now after this, we're going to look at how to find a short side. So post your answer in this chat. All right, so post your answers in the chat. You can just write AB. Let's write AB equal whatever meters, and XZ equals whatever you get meters. All right, in one message. All right, so I'm seeing some students posting some answers. All right, I'm seeing Nikayla. Okay, and Duhini. Bella. I'm seeing 3 posts. All right, keep it coming, all right? You might need a calculator to do this, yeah? Because the square root of 25 was kind of simple, you know? The square root of 25 is just 5.
So
All right, so I'm seeing some answers coming in. They all seem correct. In fact, all of them are correct. Very good. All right.
I
I'm
got the
seeing-
same thing.
Right, I'm seeing Nikayla, hold on here, some people. I'm seeing Nikayla, Tuhini. Macintosh, Alexia, Kendra Lee, and Tuhini saying that she made an error. And Renee Abrams. All of you are correct. All right. All right, so I'm gonna go through. Any volunteers to anybody want to volunteer to explain how you work out the first one? AB, who wants to do that one? All right, so we use Pythagoras theorem. So we say AB square is equal to 20 square plus 21 square. All right, what is 20 square, class?
400.
It's 400. And what's 21 square?
441.
441. And what's sum of all of this?
841.
Right, and then we just find the square root. So therefore AB would have been the square root of and the square root of 841 is
29.
29 meters.
Meters.
Very good. All right, any questions? What the following? It's pretty straightforward, isn't it? All right, this one, you know, is the same idea. So xz.
Excuse me, sir.
Yes.
So why didn't you use takeaway
Why didn't I use takeaway
or subtract?
or subtract? All right, good question. Is it because whenever you want to find the longest side, if you notice, AB is a hypotenuse, that's true. And XY is also, XZ is also the what? The hypotenuse. So whenever you want to find the hypotenuse, class, you don't subtract, you add. So you just use this formula here. Okay? We're gonna look at where we subtract. Okay, right after this. So xz squared is equal to 35 squares. It doesn't matter which one you want to write first here. Write any one of them. All right, what is 35 square, class?
1,225.
1,225. And what's the sum of 1,225 plus 144?
1369.
1,369.
One person, just go again. What is it?
I said
1,000.
1369. Sorry.
1,069?
1369.
Or 1,300. 369. And the root of that is
37.
37. Beautiful. Very good. And that is xz. Anybody writing?
No.
Yes, sir.
All right.
Okay.
So what we're going to look at next, you see?
Sir?
Yes?
Yeah, I'm having a challenge with the square root on my computer, on my calculator.
On your calculator?
I'm not sure how to use it. Yes.
Oh. What brand is, can you just take a photo of it and send it to me personally in WhatsApp? Let me look at it.
Okay, sir.
Let me tell you, Mrs. Walker, it's either, let me tell you, it's either you, tell me why is it you're not getting? Is it just not getting the answer?
Yes, I'm not getting the answer.
Tell me what you press. What do you do?
I put the number first and then the root, square root.
All right, send a photo of the, a focus photo. Especially where the square root sign is, because sometimes, you know, calculus vary. Yes, I hear someone saying something.
What's her error? Because if I put in the digit and then press square root, it gives me scientific error. So I do square root sign first and then put in the figure and I get the answer. So
Oh,
I try to try that.
okay, yes. So some calculators, you know,
What you have to do, sir?
Hmm?
I wanna ask you to press the square root first and then punch in the number.
Right.
No, it depends on some brand, you know, because let me tell you, some calculators,
Yeah, I'm not getting it.
the square root sign is a second function. Means it is not the original function button. So different brands vary. All right, so Mrs. Walker had sent me a message. Let me just check to see.
Sir, I'm finished.
You finished?
Yes, sir.
Okay. Oh, Mrs. Walker, I think you should press the number first, yeah? Press the number first. Press 25. Then press the button. You should get the answer.
And it's the one with the X underneath it, right?
Right, man. Yes. It's the one with the symbol and X, right? I think you have to press the number first, then you press the button.
Well, I didn't try the 25 because normally I don't know if it's changing. So
Right.
I press 35.
No, man. Okay.
And then I get, and then I get 5.91.
That means that work now. I think what you were doing was pressing the button first. Not true. Then you put in a number, and then nothing is happening.
Not moving, right?
Right. So that
but 35, but 35 square root is 1,225. But I get 5.91 on the calculator.
Come again. The square root of
35. 1,225. But when I do it, I get 5.91.
Where the 1,000 come from?
Because I'm looking at the last math, XZ on your screen. Square root of 35.
I don't have that. I don't have a square root of 35.
It's not the square root. Yet it's not the square root times 35 2 times.
Oh.
Oh.
Yes, Mrs. Walker. The 35 square is not is 35 times 35 and 12 times 12. All right.
Oh.
Right. So it's when you reach down here, so.
Okay.
It's when you reach down here, so you do that.
Oh. Okay, I got it.
Do me a favor, press 1369 and press square root until you get 37.
Yes, sir.
Right, very good. Okay. All right. So we can probably move on now.
Yes.
All right. So we're going to look at two questions where we want to find a short side. And let me show you how this thing kind of, it takes a little bit more effort when the side is short. All right, so example. Now you notice all my examples, I give you perfect, nice whole numbers, that's true. Yeah, I'm just doing it because of convenience. So let's look at this question here. All right, now suppose this is 17, right? 17 centimeters. And this is 15 centimeters.
On the screen.
You're not seeing my screen?
Okay.
All right, let me stop share and start share again. Let me see. Any better?
Yeah, I'm seeing it now.
All right. All right. No. So the question is find this side. Find side B to C. Now to find, well, first of all, you need to ask yourself this question. Is it a short side or a long side? Obviously it's a short side, don't you? Because the 17 would have been the what?
The long side or the hypotenuse.
The hypotenuse, right? So here we're going to know. No, let us start off with our original formula. Our original formula states that a squared plus b squared is equal to c squared. That's the original formula, true? In other words, forget about these letters, A, B, C. So the A and the B would have represented the two short sides, and the C would have represented the long side, which is called the hypotenuse. Now, in this example there, we're given the hypotenuse. So what you're going to do is that you write equal 17 square on the right-hand side here of the equation. What the following? And then now you can pick and choose which one you want to select for A and B to be the short side. Well, no, let me say it again. You can select, well, it's two short sides, but only one is given. So what you do, you just write one of them anywhere. So that's going to be 15 square. And then the missing side now would have been BC square. What the following?
Yes, sir.
Let me write it properly. So that's 15 square.
Breaking up.
I'm breaking up. Okay, is everybody hearing me?
I'm hearing you, sir.
Okay. All right. Too much fun in the background, man. Too much breeze. All right. So a square, let's call a square BC square. So it's BC square. So what we need to do, class, is to find what? BC square. All right. So what we're going to do is, see, it's an equation. So I don't need this plus 15 square. And to get rid of plus 15 square, back in the day when you're doing equations, well, no, you know, we're not gonna find the square root. We're gonna subtract
So we're
15.
going to
We're gonna subtract 15 square.
Subtract 15 on the right and 15 on the left.
Yes, man. But you know the thing, man. You miss?
Yes, sir.
So to get rid of 15 square on the left, we subtract it on the left and also on the right. So this will go away, ladies and gentlemen. So what left back is just what? 50 is just BC square. All right. What is 17 square, class? What is 17 times 17?
289.
289. And 15, what's 15 times and what's 15 times 15?
225.
225. And what's the difference of those two numbers here?
64.
64.
Maybe 8.
And then what's the square root of 64? 8.
8.
Yes.
And that's it.
Hmm.
So there you go. Any questions?
Sir, you can just go back from the top part.
That's all of it here.
So, sir, but with the other one,
Mm-hmm.
it-
When
the-
hold on,
the-
when is the other one? You're talking about the one. Hold on. When is the other one? You're talking about the
Ones
one with
before.
the long
the
side.
ones,
The ones before.
yes, it work out seem shorter than this side, than this one.
Or you're making an observation.
So, I did work, yeah, I did work it out and get the answer. What I was looking at how you were working it out.
Okay.
It's longer.
And that's a problem, not true?
No, I didn't have a problem. It's just that I followed the shorter step of the ones before.
No, it wouldn't be a shorter step in it. It's just that this it's just that the step goes short. Can I move on? All right. I'm going to give you a question to try.
Sir, you're going to send that in the group.
But Gabriel, if I have it on YouTube, yeah, I'm going to send. Right.
Oh,
Yeah, man.
YouTube. Okay, like right after this class, you're gonna send it to YouTube, upload it to YouTube.
Probably a couple hours afterwards.
All right.
All right, so I'm gonna go to a question. Just give me a minute there. Computer is running a bit slow. so it's up. I'm going to share my screen. All right, everybody see my screen? Everybody see the question?
I'm seeing it.
All right, please take out that question and try it. I'm going to give you let me tell you, because I mean it's kind of hard to just swing on question like this and you probably as a boy, sir, what kind of sickness. So these have two triangles, true. It's two right angle triangle. All right. So let me explain to you how to solve it, and you solve it. Oh, that sound like a reasonable deal, not true?
Screen gone blank.
Hold on. I think I know what the problem is. All right. I don't know why it keeps doing that. All right, tell you what. Let me go to this thing of marketing. All right. So let me explain what to do, right? All right. So the question says to find BD. All right. So what to do? Ignore this side of the triangle. All right, and just focus on over here, the left hand side. Now, would you agree with me that BD is a short side?
Yes, sir.
Yup.
I couldn't someone else with that question a while ago.
So it.
The 17 and 15 I gave you a while ago. Correct?
Yes, sir.
All right, boy, this is a giveaway. Anyways, you get rid of it. But anyways, so you work out BD, which is a short side, and you're good. Whatever value you get for BD, the question goes on to say find what? AC.
AC.
Now AC is all of this. So what you're going to do is see, whatever number you get for BD, and you all know it, you're going to use it with the 13 and find DC.
And then add DC with 15.
15. All right. Very good. Yes, that's exactly what you're going to do. So the answer you get for the 17 and 15, you use it with the 13 to find DC. And by the way, DC is another what? It's another short side because 13 is the hypotenuse, as you can see. And the question says to find AC. So when you find DC, just add 15 to it because this 15 is right here. So you all see that? You guys understand?
So repeat for me, please.
Yes, sir.
All right, let's go again. Let's go again. We have two triangles here, all right? We have two right angle triangles, one on the left, one on the right. So the question says to find BD. All right, now BD actually attaches the left hand triangle and the right hand triangle. Now, why we can't use, let me ask a question. It's a good thing you say you understand, because I wouldn't remember to ask this question. Why we can't use the triangle on the right to work out BD as it is now? Why is the left one triangle have used?
It only has one value.
Exactly. It only have what?
One value.
One value. But with Pythagoras, how many values do we need?
Oh.
We need 2. All right. So we use the left hand triangle because they give us what? 2 values. We know the long side and we know the short side. So we're going to subtract to get the BD, which is a short side. Follow?
Yes.
Now, when you get BD, let us say BD is say 7. Let's say I get 7, right? The question says to find AC. AC is just all of this thing here. So to find AC, what are you going to find D to C? But DC is a short side. So we're going to use a 13, which is the long side, and a 7 to find DC. Follow? And then when you get the answer for DC, you add it to 15 to get the length of AC. Because the question didn't say to find the length of DC, the question says to find the length of A to C. All right, so I'm going to give you 5 minutes or less to compute that.
Finish explaining, sir.
Sir. Sir.
All right. Okay, so what is BD?
8
It's
centimeter.
8, don't you? Yeah, we just worked it out. Like, don't you? I didn't realize. All right. And then to find DC, which is another short side, you're gonna say DC. Let me use a different color. DC would be when it's going to be 13 square subtract 8 square. So you'd have to start off with you have to start off with a square plus what? B square equals what? C square, don't you? And then you subtract on the left, on the right, and you end up with this. And what is 13 square?
169.
And 8 square is?
64.
What's the difference of those two values?
105.
105.
And the square root of 10.25.
10.2. Let's call 10.3.
Okay.
Yeah, I didn't actually specify how much decimal place. So this is 10.3 centimeter. All right, and to find the whole AC, just add the 15 and the 10.3. And that would give us what? 25.3 centimeters. That's our answer. All right, any questions?
So I just joined, so I'm not even sure. I'm having an internet issues.
Okay. Well, the weather is a factor. And Zoom takes up a lot of data. It takes up a lot of internet because it is transmitted in high definition. I don't know why. Right. All right. Mrs. Walker, you have to just catch the recording here in the interest of time.
Okay.
All right. So, ladies and gentlemen, this is actually Pythagoras.
Yes.
Question? All right. Let me
Sir,
show-
don't take this off yet.
All right. So I'm going to show you one more thing in Pythagoras, then I move on to trigonometry. But before I move on, I say 1 point. Remember, Pythagoras only works with right angle triangle. Pythagoras only find unknown sides when two sides are given. Very, very important thing to remember.
Sir,
Yes, finish?
yeah. Yes, sir. But
right.
sir, I have a class with Mr. Shaw at, what is it, 4:30? 4:30. So I'm gonna have to leave early.
Okay, all right, no problem.
All right. Oh my gosh, it's 4:44 now. Anyway. Bye, sir.
Okay. I'm gonna move this. Okay, let me just share one more point with you on Pythagoras theorem. Then we'll move on to understanding basic trigonometry. And if you can understand basic trigonometry, you can understand the advanced aspect of trigonometry. All right. And so some students fear this topic here. This is a very talked about topic. Even songs are being sung about this thing here. Song about don't know how much about biology. And something there. Yeah.
A song?
Yeah, there's a song.
No.
Yeah, man. Even movie clips. I feel trigonometry or something like that, or something with trigonometry. All right, so it's just a cultural thing. All right. As I was saying, all right, let me share my screen. Let me try and use a whiteboard. All right, so this thing on whiteboard. All right, now you have something called Pythagorean triples.
Yes, sir, I know that.
All right,
Isn't it like the 3, 4, 5?
right.
thing?
Pythagorean triples. So basically what they're saying is, if you have a right angle triangle, right? This is 3, and if this is 4. What they're saying that when you work it out, you'll get 5. So they call it 3, 3, 4, 5. So the 3 and the 4 would be the two short sides, and the last number would be the hypotenuse, would have been the 5. So 3, 4, 5, that combination is a Pythagorean triple. All right, so these are special numbers. Nobody has a boy 6, 7, 8, 9, 10, 11. It doesn't work like that. So you have 3, 4, 5. In other words, let me show you something. If you make, say, this is 3, and I ask you to find this side, it would have to be what? 4, no matter how you work it out. Or if I give you the 4 and the 5, you'll get 3. So in other words, some of these questions you don't have to work out. You just know say boy 3, 4, and 5. All right, you guys follow?
Yes, sir. But wait, let me check coffee.
Let
Yes, sir.
me give you a set of numbers. So sometimes in multiple choice, Let me tell you, there's this question in CXE. Where is this thing here, man? Where they have a question like this, like they have a wall and they have the floor, right? So this is a wall. And there's a ladder leaning against the wall. I don't know if you have ever seen a question like that before. All right. And the question says the length of the ladder is 5 meters, right? And the distance between the base of the ladder and the wall is 3 meters. The question says, what is the height of the ladder? What's the height of the wall? Obviously, it will be what? 4.
4.
Because 1, it's a right angle triangle. The ladder would have been the hypotenuse. All right. And in less than a second, not even 1 second, probably a millisecond, you work it out, and boom. That's one question. All right. So let me give you some other triples. You have 6.
So they don't give you like to prove your answer.
It's a multiple choice. You understand? It's a multiple choice question. So the length of the ladder is 5 meters. The distance between the foot of the ladder and the base of the wall is 3 meters. What is the height of the wall? So you know, so Pythagoras. So 3, 4, 5. So this must be 4. All right. So this is another triple. 6, 8, 10. So the 6 and the 8 are the two short sides, and 10 would have been the longest side. You have 5, 12, and 30. All right. Let me give you another one. Eight, 5, and 17. And it goes on and on. So that's what we call Pythagorean triples. I'm not gonna lie to you, when I first learned this, I used to call it Pythagoras triplet. One teacher said, wait, I say, triplet, it's not some baby thing. It's a no brass and a triplet. It's triples, About 3 years, every time I fight, I went triplets. So, and then I realized it's not triplets, it's actually triples. All right. So these are some examples. So in CXC, the most popular one is 3, 4, 5. And I've seen 6, 8, 10 already in CXC. But it must be a right angle triangle. And you must have 2 sides. All right. Can I close this?
Yes, sir, you may.
All right.
Oh.
So we're going to look at the thing called trigonometry. All right. Or should I say basic trigonometry? Let me share my screen. Some people just call it tricks. But the word is too long. All right, now trigonometry. What is trigonometry? It's a study of triangle. It's a study of triangle. It is a study of triangles and the geometry of triangles, basically. It's really about triangles, the geometry of triangles. If you look at the word trigonometry, you can get those things out. All right, so what is so special about trigonometry? All right, now so for basic, remember we're doing basic trigonometry. All right, so it focuses on right-angled triangles. All right, for now, well, for the first part. All right, what do we use trigonometry to? So we use trigs to find unknown sides and angles. Yes. So that's what trigonometry is. Kind of powerful. So you can find a side and a what? An angle. All right. Now, did you know that when a plane is landing on an airstrip, the plane has to tilt at a certain angle called the angle of depression. And if they don't tilt the plane at a certain angle to land, what will happen? What can happen? Madness, is true. Yeah, man. The plane can crash. The plane can actually run off the runway. It can crash and split in two. All right, and let me tell you that, and they have to use trigonometry, believe it or not, to actually calculate the best angle, or they call it the angle of descent. All right, so what they do is to use radars, signals, like electromagnetic waves, to measure the distance between, say, the plane and the airstrip, and it will calculate the angle of descent. And likewise, when a plane is ascending. Yeah, man. So this is very important in aviation. And if any of you guys get a chance to study piloting, or those things, helicopter business, that's very important. There's a machine that they use, it's called a clinometer, to measure it, or they use a digital clinometer. All right, so it's very important in aviation and in marine studies too, I should say. So we use trigonometry to find unknown sides and unknown angles. All right, now in trigonometry, we have something called the trig ratios. All right, now what's a ratio? It's really a fraction, not true? X divided by y. Now what are the trig ratios? Sine,
cosine, and tangent.
right? Cosine and tangent. All right, so for short, sin, sin, cos, and for short, for tangent, we just use, say, what? Tan. And if you notice on your scientific calculators, those buttons are there, not true? Give me a second.
Yes.
Give me a minute. Give me a second. All right, sorry about that. Right. So the trig ratios, sine, cosine, and tangent. Now, what are the trig ratios? What are they for? Where they come from? Like those buttons on the calculator. When you press them, you see some things, right? So for example, all right, for those of you who have your scientific calculator, right? Please take them out. All right, now, let me see. Okay, I know you're not seeing my screen. Can somebody send me personally a photo of your who have a sharp scientific calculator? Send a photo of a sharp scientific calculator, please. I just want to share it with the class. It has to be a clear photo, yeah? clean. If you have a sharp calculator, just send it for me, please. All right, so I'm here waiting patiently. So this is or send in the group or something. All right, thank you. Is that Anna K? All right, awesome.
Yes. Yeah.
Oh, well, Anna K, turn on the phone. Turn it, turn it on, please. Turn it on and send it back. Yeah, something I want to show everybody. Sorry about that. You have to turn it on, yeah. Let me see the screen here. All right. The point I was trying to make, you see, because time is running. You see a scientific calculator? It must have DEG on the screen. So that is not showing me. Are you guys seeing this calculator here? Do you see DEG?
It's a bit blurry.
Yeah, it's a
but
bit blurred,
yes.
right? But if you have a scientific calculator, it must have DEG on it. Or if there's no DEG on it, a D must be there.
Okay, I have the D. The D alone.
And the D represents degree mode. So there are three modes. You have D, R, and G. If it is in R, if it is in G mode or rad or grad, you can't use it to work trigonometry. It has to be in degree mode. All right. Now, you see the sharp calculator. What I don't like about the sharp calculator is that there's a button on it that actually, okay, do you see what's happening here? The top right button that says DRG. Can you see my screen? Look at the top right button that says DRG on the sharp calculator.
Yes, sir.
Right. What happened is it? Sometimes, and we accidentally catch it and it's not in D mode. It's actually in R and G mode because there's a button that if you just press it, so it will just change. And that's a caution. All right. So, but you can reset the calculator still. All right. So that's very important. All right. So
even for even for ordinary calculating to it can be used the DEG.
Yes, man, but not for trigonometry. It has to be in D mode. All right. When you can use R mode, but not for C-sec.
Okay.
All right. And what I've noticed is it, you have some phones, you know. That's why sometimes I don't recommend the phones to as calculators. Sometimes some phones, the factory setting by default on their phone is actually in R mode. You know, but you have some phones that can actually change the thing. But I don't recommend using the phone, right? All right, so what does sine 30 degrees equal 0.5? What does it mean? You know? You know, what does cos what does cos 60 degrees equal 0.5? What does tan 45 degrees equal 1 mean? What does it mean? By the way, do me a favor, press. All right, Mrs. Walker, your calculator is a bit different. So for the rest of all right, let me tell you something. If you have a calculator, is it? When you press sine and tan and cos, the word actually comes up. This is what you do. You just press sine 30, press equal, you get 0.5. Can everybody do that for me? If your calculator doesn't show up any other values, what you have to do is press 0.5, then press sine. But for the other calculators, if you press sine 30, cos 60, tan 45, you get 0.5, 0.5, and 1. Can you just confirm that you got those?
Go again, sir.
All right, can you see my screen?
Yeah, I'm seeing, okay.
All right. Except for you,
So
Mrs.
it's
Walker.
by calculator.
Hold on, Mrs. Walker. Except for Mrs. Walker and probably a few others. Some calculators, you see, are kind of updated. The updated calculators are the ones that when you press sine, cos, and tan, you actually see the word comes on it. Those are the updated calculators.
Okay.
To work out this, you just press what you see. So you press sine, you see sine, you press sine, you see 30, you press 30, you see equal, you press equal, and you get 0.5. But for Mrs. Walker and probably others that have a calculator,
The other way around.
it's the other way around. What you do, you press the 30, then you press the sine, then you press equal. Right.
And I get the 0.5.
Right, right.
Yes,
So,
sir.
can you all confirm to me that you actually get these values? Everybody?
Yes,
Sir.
Beautiful. All right. Now, if you don't get 0.5 on 1, it means that 1, your calculator is not in degree mode. All right. Is anybody in here not getting those values? You need to change the mode of the calculator, all right? So
Sir, I am not getting it.
you're getting it or you're not getting it?
I am not getting it. I'm using a sharp.
You're using your
Sharp.
sharp. All right. What is on the screen? Do you see a D on this? Do you see a R on the screen?
Yes, sir.
All right. Hold on. Tell me something. Is your phone like this? Is it like, does it look like this? On my screen.
Yes, sir. Yes, sir.
All right. You see this button here, so the button that says DRG?
Yes, sir.
Press it until you see D comes on your screen. When you press that button, some things is changing on the screen.
Yes, sir.
All right. Is D on the screen?
Yes, sir.
All right. Try to work it out now. You're supposed to get them now. Let me know when you get it there.
Yes, sir.
All right. Beautiful. You see, that's a problem with the sharp, you know. Is it because the button is right there? Sometimes your hand must accidentally touch it, you know. And you know, but whenever in exams and in any questions like these, ensure say it is in D mode. All right. All right. So now that we've gotten that one. Oh, let me show you something else. All right. So I'm not going to show you. Let us explore what this thing means. All right. So what does sine 30 equals 0.5? Well, 0.5 is the same thing as a half. Correct? 1/2.
Yes,
all right?
sir.
Right. No, what happened? Let me tell you what happened. Many years ago, you see, somebody found out, I don't know who. Some students said, boy, if you find out who, I'm gonna kill them. Jokingly. Jokingly. Find something. And so, you know, probably, you know.
The stress that put us under.
No, but
They
planes
reach that
wouldn't
point.
exist, you know. Planes wouldn't exist, you know. Aviation wouldn't exist. I'm telling you. Some of the things that we enjoy is because of many inventions. Many things that we enjoy, we take for granted. All right. So many years ago, right? Somebody discovered that whenever you have a 30-degree triangle. All right, so talk to me now. Which side is the, let me see if you remember anything from the teacher. ABC. Which side is the hypotenuse?
AC.
Right. Which side is the adjacent side?
BC.
BT.
Very good. No learn, man. And therefore this must be the what? The opposite. No, so many years ago, somebody drew a right angle triangle, right? And what they've noticed that whenever it's at 30 degrees, the ratio between the opposite and the hypotenuse, the ratio between, in other words, between these two lines here, so what I'm realizing, him say, one is always in a 1:2 ratio. Means if this was 1 centimeter, this is 2 centimeters. If this was 10 centimeters, this is what? 20 centimeters. It's always double for the hypotenuse. So if a person write it down, and that is how sine 30 equals 0.5. It means that so therefore sine 30 means that the ratio between the opposite and the hypotenuse back in those times, which is still the same time now, was in a 1:2 ratio. All right. And what they do now is to encode those information in the calculator. So we are able to work out sine 31, sine 32. So they use programs. Back when I was in high school, when calculators weren't so popular, scientific weren't so popular, we had to use the back of our books. You ever notice at the back of math book is one bag of table of a number? You ever notice it? Notice that before?
Yes.
Yes, man. Look back in the maths book.
Yes.
You see one long list of numbers. That is what I had to use. But look, fortunately for me, I had a scientific calculator. You know, it was like iPhone back in those times. So yeah, man. So you have to use the back of your book to work out sine 31, sine 32, sine 33, etc., etc.
That's why I never understand those math circles. I just think in any workout for me.
No, man. The teacher need a motivator, man. Or you probably were schooling class.
No, sir.
And
no.
You know,
A good girl.
School class. And I read notebook and something. Mills and Boons. All right. So So sine 30 is equal to 0. So what does sine mean, class? The form for sine is, so sine of an angle, sine of an angle. So you notice, whenever you have sine, you know, beside it must be a what? An angle. So sine of an angle is equal to, hold on.
Opposite over hypotenuse.
Right. The opposite side divided by the what? The hypotenuse. All right. Or for short, some call it so. So means what? So O is the what? The numerator. O is the numerator and H is the what? The denominator. All right. So that's what sine is. All right. And then no, the same thing with cos. But cos of a different formula. Right? So the cosine of an angle, so it's always have to be an angle here. So when you have sine, cos, and tan, what must be beside it? An angle.
An angle
Is equal to
adjacent over hypotenuse.
right, adjacent over hypotenuse. All right, or
So it's a 1-to-2 ratio then.
well, yes, it's a 1-to-2 ratio for this one, yeah. Well, I'm not saying that for all angles. I'm not saying when it's 60. It's a 1-to-2, but for other numbers, you have a different value. But I just want to explain something. It's when you press those numbers, when you press sine 40, sine some, it's the numbers that you see, they're ratios. They're actually fractions between opposite and hypotenuse, etc., etc. That's what it means. All right. So you have cosine of an angle.
So sir, when I press tan, you're going to see one come up, you know. So would that be like a 1-to-1 ratio?
No, it wouldn't be a 1-to-1. It have to be a 1-to-1 ratio. Because
That
one
means
divided by 1 gives you 1, not true?
Shit, that's what I said.
Eh?
That's what I said.
Oh.
Or did I ask?
Okay, no, probably I thought you said 1-to-2.
No, I said 1-to-1.
Right, yes, so right. Very good. So tangent, no. So tangent of an angle must be an angle, you know, is equal to
Opposite
right.
over
Opposite
adjacent.
over adjacent.
Adjacent, right. Or TOA. All right. And then for
Go back a bit when you finish.
yeah, man, summary. So TOA is the acronym you can probably use. All right, for short. To remember all of them. So even though all these examples are actually given, these forms are given in exam here. So this is very powerful in a class. You know, so you can use trigonometry and calculate the height of a tree without actually measuring it. You know that, right? Yeah, man. For example, mountain ranges, right? Whenever they're cutting down pine trees,
you know, at a certain height, they know they're mature, they can cut them down. So, I mean, how do you test to know if how can you measure the height of a tree to cut down a tree? They use trigonometry. I said, all right, it reached a certain height now, so we can cut it down. All right, so remember, I'm not encouraging cutting down of any trees because, you know, trees are very important, but it is what it is. So we can measure the height of a building. We can, trust me, it is so applicable. It's just that, you know, with the home now and, you know, it doesn't want to pass the math, that's true. But this is very applicable in certain career fields. All right. Now, let me show you something. Let me ask something. Note. Suppose I say, if I say if sine x equal 0.5, find angle x. Well, we know it's at 30, not true? Look at the first one. Sine 30 equals 0.5, you know. But suppose me come to you and say, boy, you know, I not tell what x is, you know. So how would you find the calculator? How would you find angle x? So you're gonna use your scientific calculator now. So here what now? This is what you're gonna have to do. That's it. Okay, somebody just messaged me. When do we know how to use sine, cosine, tan? All right, so we haven't reached that part. As soon as I finish what I'm doing right now, I will show you how to answer the questions. All right, and how to determine which of them to use. That's a very good question though. Okay. Okay, so on your scientific calculator, see? Okay, are you guys seeing my screen? Are you seeing
Yes,
the?
sir.
Yes, sir.
All right.
Yes, sir.
Mrs. Walker, you have to go wait a little bit, yeah? Because is it true you're on different? All right, for those of you who have a calculator like this, or a much more updated calculator, to work this out, you see? To work this out, what you're going to do is, see? All right, let me tell you what you're going to do in the calculator first, before I say it. What you're going to do, you're going to press this button here. It's called second function. All right. Now, second function, you see, turns on. It activates the function that are on the board, the top part of the calculator. You get it? So when you press sine, cosine, tan, those are the primary functions of a calculator. But if you notice, they try to improvise, they try to cram some more things on the calculator, not true? They put something on the left, they put something on the right. Now, if you notice, you see sin to the -1, not true? So what you're going to do, you're going to press second function. When you press second function, it activates the word that is on the left, which is sin to the -1. So you press that, and you press 0.5, and you get back the 30. Can you try that for me, please? Let me say it again.
Sorry,
You get back 30. Beautiful. You press second function. When you press sine button, on a sine, you see, where you see? Sine to the -1. It's called inverse function. And when you press that now, you press 0.5, then you press equal, then you'll get the what? Get back the 30. And that's how you use your scientific calculator to get back the angle. Now, for students like Mrs. Walker, now, this is what you have to do. what you're going to have to do, you have to press 0.5 first, then you press second function, then you press sine. So just press the number first.
Okay, yes, sir.
You get it? Beautiful. Very good. All right. Is everybody getting it?
Sir, I don't see the second function on my
What brand is yours?
CASINO.
Come again? What's
It's spelled CASIO. That's
okay?
Kashi.
Do you see shift?
Yes, sir.
Right. So it's the same thing. Press shift, then press sine.
Okay, sir.
You get it?
All right. Yes, sir.
Okay, beautiful. All right. So some calculators don't use the word second function. Like for Casio, I think they use shift. If you have a Casio brand, is shift. And just for some arguments, for those of you who have a sharp, is the alpha activates the function that is on the right, to the right of the button. So if you notice, sometimes you see two things, like two things on the calculator. So the alpha activates the buttons on the right, but the second function activates the functions on the left. And I think for Casio and others, I think it's mode.
That's the one which is not on the button.
Yeah, man. Yeah. But no, what I'm saying, you have some calculators are so advanced that they have more than one functions not on the button. For example, the one I'm looking at now, if you notice, if you look at sine, you have sine to -1, and to the right you have what? A and D. Is that? So to activate the A and D, to activate the A and D, you use the alpha button. By the way, because every calculator is different, you understand? So this calculator is more advanced. This actually, the not and an or, those are electronics engineering stuff. Those are engineering stuff or binary stuff. If you're doing computer, if you do computer science, or IT programming, the and the not key and the or tables and something. All right. Okay, so let's get back to this. So now that you've mastered that, so what what you'll say here when you're writing, you'll say x is equal to sin raised to the -1. And you put 0.5. So this is how you write it. And that's equal to 30. So this is how you write it in exam or in your notes. But to do it on your calculator, you know what to do. And the same thing for the one with cos 60. You can try the one for cos 60 here. So for this one, if
not getting it.
You're not getting it.
Oh, put in the 0.5.
Yeah, man.
Cos. Let's put in the 60. Oh, yes, I get the 60.
Right. And do the same thing for tan. So if tan x equals 1, so this is tan 1. All right. So try for sine, cos, and tan inverse to see if you get back those values. And you'd have learned how to master your calculator using the trigonometry function. All right. So we're in the last wrap session of this. So what I'm going to show you now, I'm going to show you how to actually work these questions using the formulas. All right, very important, very, very, very important. A minute there. All right, so let's get into some questions now, right? And I hope we can do a past paper before, 1 or 2 questions from past papers before we end. All right. All right, so let's see, you know. All right, so let me put a question on the screen. All right, so
stuff I'm not enough right. They go send it in the group. I'm not going to write everything.
this,
Yes.
yeah, I can send it in a group here.
All right.
It's going to be on my YouTube channel anyways. Oh,
Send it in
sorry.
the group.
Well, all right. All right, so let's look at this question. All right, no. This is very important, you know, yeah? Very, very important. This is probably the most important part of the lesson. And this will tell us if you remember anything was our teacher. So we have this triangle, right? X, Y, and Z. All right, so this is a 34 degrees. All right. And this is a 27 centimeters. The question says to find XY to 2 decimal place. That's the question. All right. Let me ask a question. Why we can't use Pythagoras right here? So why we can't use Pythagoras to find XY?
Or is it because we have degree and angle? Oh,
Because we no.
Only have the length of one side.
well, fine.
Because what?
Fine.
On the one side, and give us true. We must with Pythagoras, you know. If them give you 2 sides, we can find the other one, but they only give us what? 1 side. So we can't use Pythagoras. So we won't have to use trigonometry, because in trigonometry, we notice they give you an angle and they give you a side. So you can probably make a note of that. In trigonometry, they have to give you an angle and a side. All right, so the first thing you're going to do is to label each side. Which side is hypotenuse? Which side is hypotenuse?
27, x to z.
27, the
XZ. Which side is the adjacent side?
X to y.
XY.
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 And then this must be the what?
Opposite.
Was it?
That's the first thing you do here. Then now, you ask, all right, so what you can do, you see? What you can do? Wait, all right. Oh, hold on. I just hold on, sorry about that. This is the hypotenuse. This is the opposite side. This is the adjacent side. What you're going to do now, you see, is to write down the formula. So ka toa. So you write it down, you have it in front of you. So you write down so-called toa. Then now you go to the question. The question wants us to find xy. But xy is the xy, isn't xy the adjacent? Agree?
Yes, sir.
No, let me ask a question. If we want to find the adjacent side, would you agree with me that the formula must have the adjacent in it? No, sir.
Yes, sir.
And which side them give us? Which side they gave us? H.
Hypotenuse.
So they gave us, they gave H, and we need to find what? We need to find A. Which formula of A and H in it?
Cosine.
Exactly. So that we're going to use. Alexa, you following?
Yes, sir. Yes, sir.
That's how you know which one to use here. So you basically look for what them ask for and what information we have. So we have hypotenuse. I want to find the adjacent side. So therefore it must be cos. So we're going to use what? Cos. So we'll use, hold on. So we use cos. Now, once we know which button to press, all right, we're good. So then we're going to the formula now. Now, the formula for cos, now cos, it's car, not true? But car, it's cos of an angle, not true? What's the angle? 34. What's the formula? Adjacent, which is xy, divided by the hypotenuse, which is what? 27. And that's a setting out. You want to follow?
Go back over it again, sir, please.
All right, so what's the form for cos? Cos is what? Adjacent
divided by the what? The hypotenuse. But remember, what did I say? It is cos of an what? Angle. So what must always beside the cos, the tan, and the sine, the cos, and the tan? What must always beside it?
Well,
Angle. All right. So here we are going now. If the only way one number on the beside of the angle is because the question is asking us to find the angle. You get it? So if the question is asking us to find an angle, that's the only way. That's the only way a number is not going to be there. So it is cos 34 or hold on. So cos 34 is adjacent. So the adjacent we don't know, not true. Divided by the what? The hypotenuse. All right. So then we always know is just cross multiply. 1 times x, xy. What's 1 times xy? Xy.
XY.
And 27 times cos 34 is just 27 cos 34. Now, ladies and gentlemen, please remember, you know, say, you see, all of this is one something. So let me show you something. So if you write cos 34 degrees and 27 right there, so this is not cos 3,427. Because this is just one unit by itself, one entity by itself. You get it? So it's always best to put a number to the left so you don't get confused. You follow what I'm saying?
Yes,
right?
sir.
Yeah, man. So all you need to do is punch in all these in the calculator. Just punch in 27 cos 34 and tell me what you get.
22.38 or 22.4.
So it's 22.3.
8.
What comes after the 8?
4.
4. Right. So if I set the 2 decimal place, the answer is just 22.38 centimeter. That's the answer.
That's it.
That's it.
Oh.
Hold on.
Long months?
I'll make it for the whole time, sir.
Eh?
You can't even see the share yet. No, I was out and I can't see the share part yet. It's slow on my end.
Oh, this is Zoom. Zoom. Let me tell you why I think Zoom is so takes up a lot. Zoom is operating off of the cloud. It's called cloud computing. It means that it is not from the core internet. They use an external location to store their data, like servers. Yeah, man. You know, you have some countries, you know, that just have massive servers, server machines. Massive machines that just store data. All right. Let's look at another question. Can I take it up? Can I move on?
Yes, sir.
Sir, I'm still writing.
Oh, it's writing. All right.
You can scroll back up, please.
All right. Today is Resurrection Day. I hope I was able to resurrect some maths in you guys.
No? Sir, you did.
Yeah, man. So the maths was dead and I resurrected it. All right, you still writing, ma'am? Miss?
Yes, sir.
All right. At one time I
said mom to a student and said, sir, don't call me mom. It's like probably some bad experience. But let me just, while you're writing, so basically, what you need to do, one, is to label the triangle, write out SOHCAHTOA, look for what they're asking for and what you have, determine which trig ratio form to use, then use it. All right, so essentially that's what it is.
So I'm finished.
All right, beautiful. Let's look at another question because 6 o'clock draws nigh. You just want to say that to the man, call like a death sentence, don't you? So maths exam draws nigh.
Sir, when will we get our center number?
The center number?
Yeah.
It's there, man. I don't know if that's a word about. If we're about time, are you talking about timetable?
And the timetable, yeah.
Yeah, man. That's so common. Or yourself, man. Sexy.
Okay.
Sexy spending money, you know. All right, but I'm just hoping that you guys don't make any mistakes with your name on the paper, though. That's my headache. Yeah, man, you spell your name wrong and you apply for university, and you might say, no, and I saw you and you that are wrong somebody. Yeah, man, it's great. And then to get it changed is a lot of money and it takes a lot of time. But you can't sue them, you know, because them send one document to sign for the boy where you read or where the panic. They're smart, you know. So, you know, so that's why they can charge them money then. So the money make sure the boy send one document is a proof is a boy, make sure you know the information right and signing him to it. All right. See you like George. All right.
I think they even asked for the original and one copy of birth certificate. That's all.
Oh. No, I think for colleges they probably just ask for the slip. And when the original is available, they can move forward.
Okay.
They know, you know, they can call CXC to confirm, you know, because a man cannot print on paper and say, boy, I get 10 distinctions. You know. They call CXC, they call them and find out from the source if what's on the slip is actually true. All right, so let's look at another question. P, Q, R. So the question says find PQ to 1 DP. I want somebody, I'm going to give you 2 minutes to tell me which trig ratio we're going to use. Are we going to use sine? Are we going to use cos or tan? Don't guess it now. Let me see if you can determine. Or post it in the chat. Post in the chat and tell me which trig ratio you think we're going to use. Is it sine or cosine or tan? Let me see who is on the ball. All right, I'm seeing some person posting some information. It's 15 or 16 of you. So remember, what you're going to do first is to label the triangle, write out the formula, look for what you have and what them I look for, and use that to determine, you know. I'm seeing some posts from okay, so I'm seeing almost everybody saying tan. All right. Seeing Anderson, Plummer, Michaela, Alexia, all of you are saying tan. Well, it's actually tan. Yes, it's actually tan. Very good. So this would have been the hypotenuse, the adjacent, and this would have been the opposite. All right, so ka toa. Now, which side do we have? We have O, not true?
Yeah.
Which side do we want to find? The adjacent side. So which formula have O and A in it? You're absolutely correct. It is what? Tangent. Beautiful. So we're gonna use tan or tangent. All right, but then no, use a formula. So tangent, tan of an angle 48. So the toa, the O is the numerator, so the opposite would have been 12, and the adjacent would have been what? PQ. Can somebody tell me the difference between the setting out of this question and the setting out of the example that we did a while ago? Look at the setting out of the example we did a while ago. I want to tell what's the difference.
It was a side over one number.
But in other words, the unknown divided by one, the unknown divided by a number, but this now is what? A number divided by what? Unknown, not true? So in the previous question, the unknown was a numerator, but now the unknown is the what? Denominator.
Denominator.
So the working out is going to be a little bit different. Now remember this: when the unknown, they are top, like the previous question, we multiply. But when the unknown, they are bottom, like this one, waiting we do.
Divide.
Right. Oh, here what now? This is what we do. So the unknown, they are bottom, we just switch these two numbers here, these two terms, just switch them. So we're gonna have PQ equals 12 divided by tan 48. Everybody following? So when the unknown at the bottom, we divide, but to divide it, what we do is we switch the two terms in. Can somebody tell me what is tan divided by tan? What is 12 divided by tan 48? So what is that? Just press tan divide for tan. Sorry, press 12 divide tan 48 and tell me.
Sir, 10.80.
Say that again for me. You're a bit low.
10.8.
10.80. Oh, okay. So
Sir,
also
one decimal place, you see.
okay, so it's just 10.8 then. That's it. That's it. Any questions? All right. Oh, Roman, I will post this as soon as it's downloaded. It takes a little while to upload something on YouTube because first of all, this has to be downloaded from Zoom, and then which can take a little while. It is 3 hours, and then I'll upload it. All right. Can I move on? We're almost there. We're almost to the end. Let us look at one more question. Who's tired? Anybody tired? Anybody eating bun and cheese?
So realize that for the first question you add co equal cosine 34, and for the second one you never have tan tau equal tan 48.
Come again. I didn't get that.
You understand? All right. So for the first one we use cosine, right? You add co equal cosine 34. However, for the second one, you use tan, but you never have tau equal tan 48 degrees. You understand?
Was there an error?
I don't think so, no.
Oh, you just making an observation?
Yeah, it's an observation.
Okay. All right, good. All right, let's look at this one here now.
So, sir, how do you know? How do you know which one to look for, sir?
Oh, you weren't here. You stepped out.
My computer in and out, not keeping up at all.
When was the last time you? What was the last thing you saw?
When you asked the question, you gave two angles. One of them find the XY to decimal point. And from there, so we keep out. Getting in, jumping out back shortness. So.
All right, so just hang on to this one here.
All right.
I'd have to work a question to show you. All right. So that's the question. Find angle QPR. By the way, where's angle QPR? Is it that A or is it that B? Question.
P.
It's
at P, sir.
I'm gonna say A or B.
Sir, what I said.
Oh. B.
Yeah, you're correct. Yeah, you're correct. It's at A. All right, so you have to be careful. You have to know where it is. All right. So guess what? Do we know this angle? No. So it's called theta. It's unknown. All right. So let's label the sides now. Which side is the hypotenuse?
PR.
Right. Very
12
good.
centimeter.
And which side is adjacent?
PQ.
Right. Very good. And therefore, over here, so it's going to be the opposite.
Opposite.
All right. Now,
Opposite.
now the question. Now, wait, notice, and this question is asking us to find what? An angle.
Angle.
Now, it's anytime you ask for an angle, they always give you two sides. Remember that. Whenever they're asking to find an angle, they always give two sides. Whenever they want you to find a side, they normally give you a side and an angle. All right. So, which trig ratio are we going to use? We have to look at what we have, not true? What do we have? We have A and we have what? H.
Hypotenuse.
We have so. Write it down.
Cosine.
So, car, and tau. Which formula of A and H in it?
Cosine.
Cosine.
Cosine. Yes. Ladies and gentlemen, you have to know which one to choose, you know. You have to choose the right one. Because if you press the wrong button, you're in problems. That's true. Yeah, man. Some people, man, they'll tell you that, you know.
When do you know? When do you know it's trigonometry we're dealing with different from what's the other one?
Pythagoras.
Pythagoras.
Good question.
Yes.
In Pythagoras, they always give you two sides to find one next side. So in other words, Pythagoras only finds sides when they give you two sides.
Okay.
So let me ask a question. Can I use Pythagoras and find QR? Look at QR. Side QR. Can I find side QR in this question? Yes or no?
Yes, because
Yes, sir.
Because then give us what? Two sides.
Two sides.
Two
Sorry.
Sides. We can find side QR. Yes. But does the question want us to find the side?
No.
No, I want to find the angle.
But when you find an angle, then no business about on side. You understand?
So I want to get this math right.
So with trigonometry now, Mrs. Walker, with trigonometry, we find unknown sides and unknown angles. But with Pythagoras are only what? Sides. So all right, let me write a summary. Look, PT, right? Then give you two sides. They give you two sides. You find the other. Oh boy, it's writing thing here. It just get better and better, not true? With tricks now, yeah man, it's, you know, it's like good wine, you know, all they get. With trig now, they give you an angle and what? A side. And when they give you angle and side, you're supposed to find
The other side.
what other side?
Are they?
Yes.
Or, I just want to talk in the background, or, you said the correct thing, or them give you what? Two sides. If them give you two sides, it's an angle they want you to find.
Okay.
That's how you know.
So with
That-
the side and an angle,
Mhm.
what do? You add them
No.
up and with 9.
Add them up. We talk about Mr. Walker. We do
That's what
use trigonometry.
I
So-called.
was out, so I don't know what.
What trigs mean? So-called.
Ah.
No, man. I don't know. With angle to find the other side, we use trigonometry. We use trigonometry. I think because of the internet, you kind of missed out a lot what we're doing.
Yes, sir. I think that's what it.
Yeah. But I can't. I am unable to go over that now. Here.
Yes, sir. I understand.
Yeah, man, because of time. All right. So that's a summary here. All right. So we all agree that we're gonna use So we're gonna use cos, cosine. No, notice in the class. This triangle here, they're given how many sides? 2 sides. So therefore, we're going to find the angle. So watch me now, watch carefully now. So this is how you work it out, right? So cos, do we know the angle? No, so you just put theta there or anything. Cos is adjacent. What is adjacent? What number is adjacent?
6.
Divided
6
by
centimeters.
the hypotenuse, which is what? 12. That's how you go.
Yes, sir.
What is 6 divided by 12? At a decimal.
So,
0.5. How do you find angle? We have to use second function, not true? Or shift. So it's cos inverse to get out the angle. What's cos inverse 0.5?
60. No,
Beautiful.
yeah, 60.
Beautiful. And you know, so 60 already because we have done this already, not true?
Yeah.
That's it. All right. Any questions? All right. Let us see if we can do one past paper question and call it a day. All right. And then that we'll see the yeah.
Sir,
Yes.
can I say the second part of the question, please?
Was writing.
Oh,
The answer.
60 degrees. There it goes. Let me tell you, man, if we leave here or not work a password question, it would defeat the purpose.
Sir, okay. You can move it.
All right, so let me locate a document with a question on it. You know, somebody yesterday was asking about multiple choice questions, and you know they want to see a trigonometry. All right, tell you what, let me bring up a trigonometry multiple choice question, because they're saying, boy, sir, how we are going to work out that? I want a calculator like sine 35, and so I'm saying, but I'm telling you the way they set up the question, I say you don't need a calculator. So I'm going to source 2 multiple choice password question. Then I'll go to the let me see.
Sir Stevens.
Yes, ma'am.
Have you finished marking the paper 2 test papers?
No, Gabriel. Busy eating bun and cheese.
Oh wow. So you should bring some banana cheese for me.
Yeah, man.
Bring for the whole class.
All right. I'll get a bag of bula.
Yes, definitely.
Go ahead, Mrs. Walker. Your kids beat me with the bula.
What you say, sir?
Your kids, like whenever they come class,
Oh.
like a big bag of bula. One of these days,
I'm gonna share with you why I'm so fascinated with bullets. It has to be my son. It's a joke, you know. But anyways,
I love bullet too.
all right, let me share my screen. Oh, you're not seeing it, not you? Are you guys see my screen?
Yes, sir. Blurry on my end.
All right, look at 52. Can you see 52? Can you all see 52? It's on this. It's this.
Yes, sir, I'm seeing it.
All right. It says in the right angle triangle, tan theta is. What is tan theta? So tan is what? Tan is O over what? A.
Over adjacent.
All right. Which side is the hypotenuse?
13.
AC.
AC. Which side is the adjacent side?
AB.
All right. And this is the what?
Opposite.
All right. So look at it now.
Opposite.
What value is O opposite?
5.
And what value is the adjacent?
13.
No, man. Adjacent is 12.
Yeah.
So that's the answer.
Oh yeah, sorry. 12.
5 over 12.
Yes.
B is the answer.
Okay.
Is it?
The easy answer.
Easy, man. So the multiple choice is not really hard. Is it? So on order of pass, I don't answer one question. Ready to pass?
The multiple choice ready to pass.
Let me see if we can find another multiple choice.
So you know, so the internet just report me down to that question.
You just report?
Yeah, just
All right,
come on back.
hold on. You see now? You weren't seen or you weren't on?
Internet did chip out, so just come back.
Oh, gosh. There it is here.
Just remind me the boy I'm to send for my daughter for the pizza bowl while she leave.
All right. Can I move on? All right. Let's look at oh, you know, this question repeat.
Well,
question repeat. All right, let me see if we can figure out 54. Look at 54 and see if we can figure it out. This question here.
Any answers?
My things are on my side.
Which one?
All blurry.
54.
Read the numbers for me, sir.
It's
Can't see the
130.
nu- Oh, it just come up.
Okay.
It just come up. Upside gone again.
50 over x.
Correct. So all it what them say? Them say what is what? What is tan PRQ? So tan, so where's the reference angle? Reference angle is right there, don't you? Look at it. Tan PRQ. So the reference angle is there. So you use reference angle now to label a side. So which side is the hypotenuse?
RP.
Right.
RPR.
What is it? Which side is the adjacent side?
PQ. No, yeah, QR.
Q.
RQ.
And therefore this must be the what?
Opposite.
Opposite. And tan
is opposite over adjacent.
Opposite over adjacent. Right. You cancel on a resurrect on yourself pan Easter Sunday. So it's 50 over x. So you see, you don't need a calculator. The way they set up the question, you don't need a calculator. So it would be A. All right. Let me find one more. I think there was one I was looking at.
You literally just say go and find one more. And after you find one more, you say go and find one more. So after this, you go find one more.
You know, Easter Sunday, you know, so. Come on. This one is the last one.
Okay.
Come on. This one is the last. All right. Look, yeah. The reason why I went. This was actually the first one I actually found, but somewhat just disappeared on me. Look at 59.
Sir, I'm not complaining. It's fine. Yeah.
But you can't complain in class.
Let me mix out.
All right. Look at 59. Somebody.
Heck up a little bigger, sir. Blur on mine. Maybe it get bigger.
It won't get big. It won't see it. You're using Wi-Fi or data?
Wi-Fi.
That one so probably. Why them bother by your ear?
No, I know what happens, sir.
Water like water gone in the wire, man.
I must say no car rain fall on now.
Yeah, when rain falls, the whole thing. Do you see a Z angle there?
Yes, sir.
All right. So, and is that? So if so the 30 on the outside is the 30 on the inside, so we're going to use that now. So we can figure that one. Yeah.
Sir, what's another option? What's D?
Oh, sorry.
All right.
You want me to give you a joke? Is most of
Yes.
these questions, multiple choice. I don't know. For some strange, it's always time. But I go to the exam and say, boy, I can't. But most of these questions is all I don't know. It's always time. So it's either A or C.
Let's see, sir.
See?
It just come up on the corner.
All right. In the interest of time, is it? So this angle here, this is 30 because this is an alternative angle. So even talk about depression, ignore that. So let's label the sides now. Which side is a hypotenuse?
XZ.
ZX.
ZX. Which side is the adjacent?
ZY. No,
XY.
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 XY. You see anyhow you mix this up. Remember now, the adjacent is always beside the reference and the right angle. And therefore the last one must be the opposite.
That one.
All right.
Opposite.
But you are going to know. The question says, what is the height of what? YZ. So right on so Kato. Remember in the last couple exam questions they actually tell us that they're going to use tan, not true? Them tell us about a tan they're going to use, but this one they didn't specify. So we want to find what? YZ. In other words, we want to find, so we need to find
The hypotenuse. No, I mean
O. We need to find O. Which side do we have?
we have the adjacent
A. So which formula have O and A in it?
and the angle.
Right. How's the tongue?
Car.
How's the tongue? Miss what about tongue?
It's car.
Okay, no, Mrs. Walker, it's not car.
It's your tangent.
Okay. Sorry, yeah.
Come on,
Try
tongue.
nobody knows a tongue.
A tongue.
Sorry, I said ton. A tongue. Tongue.
Yeah, tongue that he drinks. Yeah, man. Sir Ted, no, Sir brain flustered.
There was one tongue to drink
What?
with the bun.
All right. So we're gonna use tan. So tan, check this out. Tan of angle what? 30 degrees is equal to the opposite, which is YZ, divided by the adjacent, which is what? 10. What did I say? When the unknown they are top, you just multiply them. So therefore, YZ is equal to 10 tan 30. That's the answer. 10 tan 30. So therefore, it is C. Now I tell a lie. I mean, if I was in exam, and I know that I work out and get tan, it does alright. I just can put on this. Because guess what? 30 degrees and tan. Good. All right. Okay.
So, sir,
Mm-hmm.
I realized I just got mixed up a while ago. So go back up the top of the diagram.
Mm-hmm.
So they gave us the adjacent. So I know that we have that. And they asked for ZY.
O. The O, which is what? Why is it is O, you know?
Right, the upper. Huh? Yes, the O. So
Put it this way, Mrs. Walk. Mrs. Walk,
Hypotenuse.
Put it. No. The question says find what?
O.
YZ. You understand?
YZ.
Right. Yeah. So you look for we want to see there. We want to find what? O, and we have A. So the formula must have what? O and A in it.
Okay.
All right.
Yes.
So you're talking about hypotenuse. No, they didn't ask us to find a hypotenuse. Right? Okay, let's quickly look at this structured question, and then we call it a day. We're almost there. All right. We're almost at the tomb. Tiffany, all right. All right. Let's see. This one's a nice one. All right. All right. So let me share. Are you guys seeing my screen here?
Yes, sir. Well, I am.
All right, we're going to look at number 2. Is everybody seeing number 2?
Sir, blurry.
It's blurry. All right, make it separate. You seen it now?
Kind of.
Oh dear. Is everybody experienced the blurriness? Let me stop share and share again.
What it?
Are you guys seeing it now?
Still blurry.
Still
On
blurry?
mine.
I don't know what one. Anybody has experienced the blurriness?
Yes,
The
sir.
water?
You're already, sir. Number 1.
No,
Having that problem.
Number 2 is the point.
I can see it properly.
Okay, one person there seeing properly. I don't know what the problem is.
We can't figure out why they say. So that's okay.
All right. Let me. Which group are you in? Wilmot's? Which?
Yeah,
Saturday or Wednesday?
Saturday.
All right. Let me send a question to the group. You guys are seeing blank, no?
Yes, sir.
It's blank. I know. I don't know.
Sir, screen blank, I'm not seeing anything.
I know. I'm gonna
Receive, thank you.
all right, let me. All right. Everybody see it now? I just why is this thing? Oh, I think I know what the problem is. I think I figured it out. This thing means not problem. All right. Are you guys seeing the question now?
No, sir.
Oh dear. Yeah, see no, not true.
Yeah.
All right. Okay. Okay, let's just get with this. So the diagram below, not drawn to scale. This is very important, class. Not drawn to scale. It means, you know what this means? It means,
If you use our rule of image, it won't.
you can't say these two are equal. These two sides are equal. Because I got boy, it look like in a middle, you know, sir. Watch it. Sir, it look like in a middle. No, not go so. All right. That's what it means. So you can't look at this and say, boy, it's in the middle, or you can't judge it. It's not, it has to be worked out what mathematically. All right, so it says it shows 2 straight wires. So basically it's like a pole. It's a pole. So this is like a pole, like a light post. And you ever notice the light posts are supporting wires? You ever notice that? To hold them up? Yes, something like that. And it's all of this, you know, it's all of something is just to show you off. It's basically down here, sorry, right? They're just describing to you everything. What's up here. All right. Okay, so let's go. It's a calculated meters, the length of MK. So MK. Let me ask a question. Can I use the left hand triangle to find MK? Can I use the left hand triangle to find MK? No, can't use it. Because MK, hold on. Remember, I know. This is MK, right? MK is a part of the smaller triangle. But the left-hand triangle is a bigger triangle, not true? So you can't really use the left-hand triangle. All right, so let me ask a question now. So since we know, so we're going to use the right-angle triangle, right? The right triangle. How are we going to find MK? Are we going to use Pythagoras theorem or trigonometry for the right-hand triangle?
Trigonometry, because then give one side.
Our angle, yes. Very good. What you can do, you see, is to separate them. Separate the triangle, because sometimes, you know. So this is M.
Yeah.
And this is K. This is 10.
Inside is 30.
And that's 30. That's our reference angle.
Okay.
All right. Now, let us label this triangle. Which side is the hypotenuse?
10.
That's the hypotenuse. Which side is the adjacent?
MN.
MN.
Very good.
KM is the opposite.
And KM, naturally, if you try to follow it in that order, you're not going to get mixed up. If you notice, you're not being mixed up. So, class, Mrs. Walker, we want to find what? MK. Not true? Yes. So, MK is the opposite, right?
Yes, sir.
So we want to find the opposite. Which other side them give us?
Hypotenuse.
The hypotenuse. So which formula? So what's
Sine.
Yes.
So
Sine.
we have, yes, you're correct. We have H. We have H.
Yes.
And we want what?
Opposite.
Yeah.
And
How we know
O over H.
How do we know all we want? Because them tell us. Yes, and then we'll no.
Yes.
Well, technically speaking, they didn't tell us that we want O. They tell us we want MK. But when we label it with the O and the H and the A, we know say boy the MK is actually the O. So we want the O and then give us the H. So sine have O and H. So that is how we're gonna work it out. You know, say you can reason this thing out another way though. Because if you notice, all right, let me ask you a question. If you notice, if we want O and we have H, you realize that adjacent, no adjacent was given, and we don't want to find the adjacent, and no adjacent was given. So we notice anything with adjacent we're not going to use. We notice cos of adjacent and tan of adjacent. So we're not going to use it. So it must be sine. So you could reason it out that way. Look for where you don't have and where you don't want. All right?
Okay.
You could have reasoned it that way too. So rather than looking for what you have and what you want, you know, look for what you don't want and what you don't have. Boy, that sounds depressing though. Anybody, we don't have it, but it is what it is. You can reason to it that way. All right. So now that we know that we're going to use sine, let us work with it. All right. So I'm going to erase this because of space. So almost finished. Some people drop off. So sine of an angle have to be an angle. So the numerator will be opposite, which is what? MK divided by the hypotenuse, which is what? 10. What do you notice, class? The unknown is at the top. When the unknown is at the top, all we need to do is what? Just to multiply them. So MK is 10 sine 30. What is sine 30, class? No, half.
Or 0.5.
Yeah, how much half of 10?
5.
5. So MK is what? 5 meters. So that's the first part 1. I'm going to have to erase all of this here because I'm using the on-screen feature.
Hold on, sir. Hold on, sir. I just come back in. Let me just write it. Okay, go ahead.
All right. Are we good so far? I'm going to clear this here. Everything. All right. So this piece here, MK is what? 5. We just worked out. The next question says to work out what? JK. And this is this piece here. So, no, you know what some people say? Why, sir, say this well can it look like an middle there. So if this is a 5, then it's a 5. So the answer is 5. So I'm telling, so that's why they say not draw. I'm telling you, people say those things. It look, sir, look on it, man. Look good, no, sir. It look like an amiga, but but when to be fair with you, it don't look like an amiga. It look like, well, I don't know. If you to look at it, I don't know. It look like this small, I don't know.
So I have the adjacent.
So you look like in maybe.
You look like an amiga. Yeah, one of them. All right. How do you find this side here, sir? We know that it's a 5.
And the adjacent is 5. And the hypotenuse is 13. The hypotenuse is 13 and the adjacent is 5. And part of it is 5.
No. Hold on. Remember, you can't label a triangle if there's no angle. You realize that there's no angle for the left-hand triangle? So you only talk about opposite and adjacent when an angle is involved. You hear, Mrs. Walker? You follow?
Pardon me?
You only talk about adjacent and opposite when there's an angle. If you notice, no angle was given in the left-hand triangle.
Oh.
The only thing we're sure about is that 13 is the hypotenuse. That's the only thing we're sure about. But apart from that, we can't talk about 5 is the adjacent because in order for 5 to be adjacent, the reference angle has to be there. But they didn't tell us.
Okay.
Reference angle is there. Any ideas of how to find JK?
Check down again. Canberra.
No.
Alexa, I don't know.
Pythagoras, sir.
Eh?
Pythagoras.
Beautiful. Very good. Let me ask a question. Let me ask a question. If you just work on question on a right angle triangle, you know, most expect that the other triangle we need to use to work out something, true? Class, if you're to I'm gonna separate this triangle here. Oh, yes, Ms. Walker. It's two theories in one question. that is the reason why I specifically chose this question here, because I knew it brought out concept of Pythagoras and concept of trigonometry. All right, so this is L. This is 5 meters. And this is M. This is our right angle triangle here. And this is 13. And this is J. Now, class, can't we find this side here, so?
Yeah.
Using PT?
Define full length of JM, then subtract 5 from it, don't you?
Here Gabriel said, very good. What is JM? Isn't this a triplet? You haven't talked about triplet. Triples?
Pythagorean triple.
Yeah, 5. No one triple.
No, 5.
Look at the examples I gave you.
3, 4, 5.
Is it a triple? I don't remember.
5, 12, 13.
But
No,
yes,
sir, 12, 13.
Then I see the man 5, 12. So the other one is 12.
And then I'm still.
Isn't it 3,
Yes.
4, 5? What?
5, 12, 13 is a triple.
Oh, why?
Because no, it's given, Gabriel, it's given. I gave some examples of triples. All right, tell her, you can actually work it out, you know. You're supposed to work it out as a matter of fact. So let's work it out. Is it a short side? It's a short side, don't you? So therefore, we start off with the equation. We have a squared plus b squared equals c squared. All right. So c squared is the longest side, which is what? 13 squares. So that's 13 squared. And we have one on the short side, which is what? 5 squared. And this would have to be jm squared. And then long short, what is that? Long shortcut, whatever. Jm is going to equal to the square root of 13 squared subtract 5 squared. All right, 13 squared is what? 169 minus 25. What's 25 from 169? 144. What's the square root of 144?
12.
12. So the entire thing, ladies and gentlemen, is what?
Sorry?
Is 12 meters. Yes.
Sir, I have to leave again. I'm late
Okay.
for another class.
All right. But this piece down here says what? 5, not true, from the previous question. So to get JK, we just subtract what? 5 from 12. So the answer is what? 7 meters. All right. Let me tell you something. Any question that comes in the section 1, you guys should be able to answer this now. All right.
But I mean, me in and out, so I know me not get.
All right. Just wait. I'm gonna upload to YouTube here. So, ladies and gentlemen, I'll see you guys. Bye-bye.
Bye, sir.
All right. Bye-bye.
Bye, sir.
All right. Take it easy.
Thanks for today.
Yeah, man. Get to the money.
Bye,
sir.
All right.
Sir, before you leave, where is he?
Gabriel, Gabriel, this is recorded here. You have to WhatsApp me.
Oh, never mind.